Okay, so yesterday we did cos of x equals to x, okay? And some of you may think, oh, it's a pretty trivial and I don't need to graph and go through all the trouble. But if you have cos of 2x equals to x and you're asked to plot it, it may be a bit tricky or may take you a while to actually find the real number of solutions. And even then, you may not be really sure if it's correct or not, okay? So we'll try to do a problem here. Okay, first of all, again, we do the same thing as we did before. And our step 1 would be to restrict the domain. Okay, again, cos of 2x lies between -1 to 1. Okay, so x can only belong to -1 to 1. Okay, now then let's see the step 2. Okay, let's see what our f of x is. Okay, first of all, let's see, like before, can we rule out the -1 to 0 interval? Okay, let x equals to -1. Okay, I get cos of -2, which is same as cos of 2, and that tells me it is actually, if you see, cos of 2 is a negative number. It is more than pi over 2, which is 1.07 radians, something like that. Okay, so it is negative. So it's actually possible that I may have at this equal to a negative number. So there may be some value of x where I may have my between when x belongs to -1 to 0, I may have cos of 2x equals to x. Okay, so I cannot rule out the -1 to 0 interval. All right, so let's see what we can do. In that case, let's just go to the next step, which was to write f of x as cos of 2x minus x. Okay, and I try to see what does this behave like. Okay, I see, I differentiate it, and I get -2 sine 2x minus 1, keeping in mind that my domain is this. Okay, all right, now that this is my domain, I get, and I try to see, is it always increasing, decreasing? Do I have a critical point? And actually, I do here have a critical point, because that is going to be equals to 1 over 2. Minus 1 over 2, right? Okay, so now that I have this, and let's see, can I find a value of x such that x belongs to this and that sine of 2x is minus half? Okay, this is pretty easy because I know it's sine 2x is minus half when x equals 2x has to be equals to minus pi over 6, right? Because sine pi over 6 is half, sine minus pi over 6 is minus half. Okay, that means x equals to minus pi over 12. Oh, very good. As a result, we have a critical point at x equals to minus pi over 12, which belongs in our domain. Okay, now let's try to see, classify this critical point. Is it a maxima or a minima? So to do that, we do the second derivative. What is the second derivative? The second derivative is just minus 4 cos 2x. Okay, and that at x equals to minus pi over 12. What is the value of that? That is minus 4 cos pi over, well, it's a negative here, so it doesn't matter because cos of a negative function is just minus pi over 6, which is just minus 4 cos pi over 6. And that is going to be, this is a positive number, so it is a negative number. As a result, I learn that x equals to minus pi over 12 is a maximum. Okay, interesting. Now, what can I do? I know that if I try to plot it roughly, my minus pi over 12 is going, let's say this is my minus 1, this is my 1, okay? Minus pi over 12 is here somewhere, and I have a local maxima, okay? Now I just need to know if this is okay. There are no other critical points, okay? So it between -1 and 1. So it can only behave either like this, okay? Or it could even be like this, but here it's like this, something like that. Or I don't know that, okay? I don't know. So I want to know the number of critical points at this point. So first, to do that, I check the endpoints. What is my f of -1, which is cos of -2 minus of -1, which is cos of 2 plus 1. And cos of 2, now what is cos of 2? It is going to be, let's see, it is going to be a negative number. I know that, okay. However, it's going to be a number which is less than -1, right? So that means this is going to be overall greater than 0, okay. So I made two assumptions. I erased the other one, which was that at -1, my curve is something. Let's be careful, because somewhere around here is my claim, is my minima here. So it is something like this, okay? All right, so let's just, for the sake of clarity, also check what is f of 0. F of 0 is just cos of 0 minus 0, which is 1, which is greater than 0. Okay, so I have, but it has to be less than this number, something like this. Okay, what is f of 1? Okay, f of 1 is cos of 2 plus 1, right? And again, it is greater than 0. Wait a minute. It is, no, I'm sorry, it is cos of x. It's not +1, it is -1, because it is minus x. The function f of x is cos of x minus x. So cos of x minus x, this is less than 0. And I know here somewhere I have something less than 0. And we are done. I can see f of x between the interval -1 to 1 is only intersecting the x-axis once. So I have one real solution. And that is my answer. Okay, as before, I will again leave a homework exercise for the students, and that would be number of real solutions for sine of x equals to x. All right.